Welcome everyone to the October edition of Stuck on a Bucket, put on by KMC Controls to share technical tips and tricks. I'm filling in for our regular host today. My name is Skye Bryant, and I've been the silent partner here at Stuck on a Bucket for some time now. I'm joined by Dave Bohlmann, KMC's Vice President of Technology, for this very special Halloween session entitled Taming the Networking Beast. And in our last several sessions, Dave shared how to troubleshoot Backnet issues using Wireshark captures. And today, we're going to be talking about everything from BBMDs to efficient point passing. If you have any questions, please post them in the chat as we go along. And just like last time, we're giving away a special patriotic KMC hat to one lucky attendee. So Dave, thank you so much for being here with me today.
Thank you again for having me.
Absolutely. Well, why don't you say we get started?
Okay. So this has been so much fun, and hopefully it's a good instruction for y'all, of course. We had talked before, as Skye said, about Wireshark and networking and that, and to kind of round it all up. My experience has been people still wonder about what do BBMDs do and how do you set those up properly without creating broadcast storms, and then there's a few other things. So that's what we're going to talk about today. So if we go back to the mid-1990s, back in the good old days, when the Backnet standard was being defined in that, they wanted to be able to hook up the field devices, Modbus, USB Modbus and LAN and so forth. But with Backnet, they wanted to be able to use the quote unquote newer technologies like Ethernet and IP in order to communicate and take advantage of them. So in other words, kind of trying to get into the 21st century in a way. So how were they going to do that? So if you talk to a Backnet person, a programmer, or someone that's in the standard, and that back in the mid-90s, they came up with what they call Annex J as part of the standard. And Annex J defines how Backnet devices will talk to each other using the internet protocols like IP and Ethernet and that. So that was all well and good, at least in the beginning, but they kind of created a little monster. So that's why it's appropriate to talk about it here on Halloween, because there are some caveats and head scratching, and then IT gets involved and there's more head scratching and that. So hopefully we can clear up some of that with BBMDs. But in order to talk about BBMDs, we do need to talk a little bit about what's called the OSI reference model, and a lot of people kind of know it, but not too familiar with it. It's just a way of defining what protocols are you going to use and how devices talk to each other. So in the normal IT world, back even from the 70s and still used today, the first three what we call layers of protocol or layers of communication are these three. There's the physical layer, which is at the bottom. And for IT, it's normally Ethernet. And so the physical layer, all that does is defines how do you convert your ones and zeros into voltage or analog signals and back and forth. And so that standard's the IEEE 802.3. So now all that means is that's how a device can connect to a physical layer and communicate digitally. But if you have more than one device connected on your Ethernet, now they have to follow a certain set of rules in order to be able to talk to each other back and forth through that Ethernet. And that is what's called the link layer. Those are the rules for that. And in the link layer, that's where we get the concept of an Ethernet MAC address. So each device on the Ethernet has a 48-bit address. Everybody, I think, is pretty familiar with that. So that's an address where the devices on the same network can talk to each other directly. And that's the Ethernet MAC address. And then above that then is what we call the network layer, which is how do you get devices on one network to be able to talk to devices on another network? And that is where the concept of the IP address and the subnet mask comes into play. So the IP address for the old IPv is called IPv4. That's 32 bits. And then, of course, we were running out of IP addresses, so they created IPv6, and that's 128 bits. But still, most of the time in the BACnet world, we deal with a 32-bit addressing. So we'll kind of stick with that. So then back in the mid-90s, again, the BACnet people in all their infinite wisdom decided to kind of redefine things. So they still have a physical layer, but for BACnet, instead of only being Ethernet, they included, of course, MSTP, which we all know and love. And there's also an IP layer. So they are using, in a way, they're using the network layer in IT world as a physical layer. And that's where it kind of gets a little complicated. On the second layer, then, in the BACnet, we have what I'll call, it's still a link layer, but I call it a MAC layer. And that is where you get your BACnet MAC address. And so for MSTP, that's 8 bits, like we know, but for BACnet Ethernet or BACnet IP, it's actually 48 bits. And we talked about that some in our Wireshark earlier. So that, again, is an address where if two devices are on the same network, they can talk directly to each other using the BACnet MAC address. And then on top of that, then it's the network layer. And here, BACnet just simply defined a network number. And that is what you use to try to talk to devices to another network. You use a network number, whereas in the IT world, you did a combination of IP address and subnet mask and so forth. And they don't really number their networks like BACnet does. So the differences are, I have it listed here. One of the key differences too, though, like I have in red here, is a BACnet network or an internetwork is what we call flat, which means every device can directly discover any other device in the network. And there really is no concept of private addresses in BACnet like there is in IT and IP. The IP network's more of a mesh kind of thing. In BACnet, you don't really have a mesh per se because everybody can talk to everybody else. And that kind of creates some issues, some problems if you're communicating on IP. So now back in the old days too, we had a thing called broadcast domains. And when I was young, we used that term kind of synonymously with a network. And Skye had a good analogy for comparing broadcast domains to a village. And Skye, you want to share that?
Well, I was reading through your slides, and it occurred to me that the domain is like a really small, old-fashioned little village, and where the neighbors can just walk over and deliver a message. They don't have to go through the post office. But to communicate with the next village over, maybe they would need to use the post office. And in the analogy, the router would serve in that capacity. Would you say that that's a fair understanding? Yep.
Yeah, that's a good way of putting it. And again, for Halloween, that's what's happening tonight. Is the neighborhood or the village is going from device to device or house to house, and then we're getting all our tricks or treats and all that. But even with a post office analogy, like Skye was saying, if I wanted to communicate to a house that's not in my postal area, I would have to go through the post office, which is a router. So in the old days, we would call a router as a gateway, and that represented that it was the gatekeeper for in a way, the broadcast messages, and we'll get into broadcast here in a minute. So one device in our network, which is, I don't know if you can see my mouse move, in one network, like in the gray area on the left there, we can talk to each other directly, and we could send broadcast messages, and we'll get to that as to why we would do that. But the broadcast messages stop or get blocked by the routers. That way you cannot send broadcast messages to the other networks or the other villages. So in a way, broadcast domain was kind of synonymous to what a network is then. It's just where your broadcast messages get stopped and where they can flow. Mm-hmm. So for both IT and BACnet, if you have two devices and they're in the same broadcast domain or the same network, they can talk to each other directly without going through the router, of course. And when they do that, they would use their link or their MAC address to do that. And you can see that in Wireshark. But if I have two devices that are on different networks, then they would use their network number and their device address, and the messages have to go through the router. So in order to talk to a different device, the requesting device has to know the network address of the destination device, sort of. And we'll get into that here more in detail in a minute. So either one, broadcast messages are really used to discover devices, but IT and BACnet do this in different ways, and they define networks and broadcast domains even differently. And again, a BACnet internetwork, which is more than one BACnet network connected to each other, they're flat. Another way of saying that is there is no private addresses. And in order to talk to another device, you have to know its MAC address and its network number, whereas in IT, you do not. So then for Ethernet, IT, and BACnet broadcasting, we use, in order to send broadcast messages, we use broadcast addresses. For Ethernet, it's the famous FFFFFF. The boundary is usually a router. It gets a little interesting if you're using VLANs, and we're not going to talk about VLANs today. That's for Ethernet. For IP, and a lot of times an IP network is synonymous with an Ethernet network. They're all on the same kind of physical trunk there. But for an IP broadcast address, it's the highest address defined by the subnet mask. And we can talk about that here in a little bit too. And you might already be familiar with that. And the boundary, again, is normally a router. For BACnet over IP, the broadcast address is the highest address defined by the standard for that network or the physical layer. And there are three types of broadcast. You can broadcast to everybody. We call that the global broadcast. You can broadcast only on your local network, or you can broadcast on a remote network, which you cannot do in IT. And you cannot do a global broadcast in IT either. But the way BACnet does it is we use BBMDs. But still, a BACnet router defines what is and is not a network. Okay. So now comes the fun part. Now I'm gonna kind of somewhat gloss over these slides. You'll be able to read them and think about them and have your favorite beverage as you do that and see what's going on. So the orange is you, pretending that you are at 192.168.7.33. That's your IP address. I show here's your Ethernet MAC address. And by a local message means that you're trying to reach to me, and my address is 7.12. And so I know that your machine over here in the orange on the left-hand side, when it tries to send a message, let's say a login message to me at 7.12, the first thing that your computer does is see, is the destination in our local network? And if it is, then it sends and it knows that by the IP address and the subnet mask. If it is, then it sends a broadcast message that we call ARP. And that broadcast message is who has this IP address. And so here is what the application layer, which is just the message itself. This is the network layer and the link layer for the source and the destination. So your computer puts all that on there. And for the destination, it sends it to the broadcast addresses. And then I receive it. I'm on the green on the right-hand side since I'm local, since I'm connected there. And I can then send a reply back saying, I am at here. And when I send that reply back, I put in that middle block there, I put in my Ethernet MAC address. So now, when your device gets my reply back, now it knows what my Ethernet MAC address is, and then it can send the message from there on. So the whole point here is to try to figure out what is my Ethernet MAC address. And so it sends a broadcast message to my IP address saying, what is your Ethernet MAC address? So that's what goes on there. If I'm remote, now it's a little different. There really is no broadcast message. It says, I'm trying to send a login message to 10.1, 10.8.43. Your machine knows that's not local. And so then it just simply sends a message out to your local router. And so you notice that in that Ethernet message, that at the link layer, it puts your router's Ethernet MAC address there. But the destination network layer address, the IP address, that's still mine. So your router gets that message, and then it figures out how to forward that message to eventually my IP router, and then I get it, and then I can send back, then we can actually start talking. So in the IT world, you never know what my Ethernet MAC address is if I am remote, if I'm on a different subnet or a different network, and you never know, and you don't need to know. And so if you're sending remote messages in IT, you do not have to send a broadcast message to find me. But in BACnet, you do, because it's a flat network. So here you're trying to do what's called a read property, this is trying to read like AV12, whatever AV12 happens to be. So you have, because BACnet is flat, you have to find out what is my network number and my MAC address. So in this example, we're pretending that I, being the green, is local. We might be on the same MSTP trunk, or we might be even on the same IP subnet. And so you would send out a who is, and you put in my device instance, which again, there's not a corollary in the IT world. And then you would send on the Ethernet, you would send it to the local Ethernet and the IP layers broadcast address, and that's what's shown in red there in that first box. But then BACnet adds its own little layer in there, and that's on the BACnet column there. And there, they're trying to take care of the networks being able to talk to each other. And so in your who is broadcast there, it says the destination network is 65535, which means I'm trying to send this who is message to all of the BACnet networks that are connected together. Now, since we are on the same network, I see that, and then my response back is the infamous IM message, and I can send that directly back to you. So when I get that who is message, I know where it came from, because that's part of the Ethernet structure there, information. So now I'm on your same network. And so the destination network in BACnet, if you're local, that's network number 0. So you have to make sure, that's just another caveat, you have to make sure when you assign BACnet network numbers, you do not use 0 because that represents the local network. So now I tack in, you see that message coming back from me, the IM, and you can read then what is my Ethernet MAC address, the 91:82 and so forth, and you know what my IP address is. So now you have my IP address and you have my Ethernet address. And really, in BACnet, on the bottom line, it shows that it uses a combination of Ethernet and the port number that we're using to create what we call the BACnet MAC address. And so that's on the bottom right where it says destination MAC. That's my address, and it's my the port number that I'm using. So in other words, the who is being used to find out my network number, which is 0 since I'm local, and then my BACnet MAC address, which is 192.168.7.12, port 47808. So from then on, when you send me a message, you have to use that, my BACnet network number and my BACnet MAC address. And then I use yours too to respond. Okay, fun. Now, if I'm on a remote network, you still have to know my BACnet MAC address and my network number, whereas in IP or IT, you don't. So you would still send out the who is, you would still send out that as a broadcast message on your local subnet. And then also you still say, I'm going to send it, I want this sent to all of the BACnet networks. And that's where the destination network number 65535 shows up. And then the BACnet routers and the BBMDs between me and you, they take care of all the magic to get your who is message eventually to me. And then when I respond back, they tack on the network numbers and they tack on my IP address and all that to eventually get back to you. And then once you have my BACnet network number and my BACnet MAC address, now you can talk to me. Now, you might have to talk through a router, and so that's why it's important. You can see there on the message coming back, the source network is 208, whereas the source network for you, I had
Dave,
it
is
somewhere
the
else.
47808 a reserved port? We had a question.
It's kind of like the default port. That's a good question. You do not have to use 47808. However, the standard requires that all the manufacturers allow you to configure 47808. A lot of people use other ports as well, but you have to at least use 47808, and which usually by default that's what people use. So, but you don't have to. But then you might, if you choose something else, then you might run into some other different protocols that use the other port number that you might use. So you just have to be careful there. So it's kind of reserved, but it's kind of not. But when the IM comes back, my router, my BACnet router tags on my source network, which is 208. Again, so now when you get the IM, eventually, now you know that I live on network 208, which is not yours. So then you know when you want to send a message back, you have to send it to your router in order to get to my network, and it has to talk to my other router or my router in order to do that. So, but it gets a little complicated. So in a way, what BACnet did was it redefined the village as kind of like a super interconnected one. So you can create what I have in red here, these two IP subnets, the one on the left and the one on the bottom right. In BACnet, by using BBMDs, I've created them as one BACnet network. And it allows me to talk to the other devices as if I'm either interconnected or the same network. It all depends on how you want to configure it. But now I can talk to the other networks, and I use the BBMDs to send broadcast messages through the IP routers, because even though the IP routers block broadcast messages, BBMD has a way of sneaking through broadcast messages, so that way the broadcast can flow no matter where you want to go. Does that kind of make sense? So, so with the BBMD, there's two functions mainly: the broadcast, and the main reason is because broadcast messages, BACnet broadcast messages from any broadcast, they're not allowed to go through an IP router. So a BBMD is a way of what we call tunneling those broadcast messages through the IP routers to get to the other network. And so what it does is it takes the BACnet broadcast message and kind of wraps it up into a special envelope into what we call a unicast message, which is just a message from one device to another. And so to the IP world, or to the IP routers, it does not look like a broadcast. It's just simply a unicast message. And that unicast message is between one BBMD and the other. The other function of a BBMD is to allow foreign devices to join a network. And foreign just means you might be somewhere out in Timbuktu, but you can join a BACnet network through a BBMD. You're probably all familiar with that one. So it's a BBMD is mainly used so devices in BACnet can discover one another. Now, and we have to do that because in order to discover, you have to send a broadcast message, but IP routers will block broadcast messages. So BBMD allows us to send broadcast messages through without the IP guys really realizing that's what's going on. Okay, and then I got a few more slides. We'll kind of go through this real quick. But in order to set up, the way you do this is you have your BBMD and my BBMD, and we have to manually configure them to know each other. And when you do that, that's what we call the BDT, or the BBMD domain table or device table. And I'm sure you're familiar with that. And so you manually configure that. And then when you do that, you kind of create a network just for the BBMDs. And so in this example, I use like network 999. So now they both know each other. So there is no special message where one BBMD can discover other BBMDs. You have to manually configure that. So then when you do all that, this is again just more detail on the outgoing. Your who is from the orange starts out, and it's just like what we had talked before. And then your router gets that message on the purple side, and then it says, oh, this is a broadcast to a broadcast network number. And then so then it forwards it, wraps it around into a unicast message. If you're trying to talk to an MSTP device on your BBMD router, then it does this local MSTP thing, like I say here. But if not, then it does the one at the bottom, and then away it goes to my router. And I don't show the network, the IP gateways, but you can look at this and look and see how the IP addresses and the port numbers get kind of used in those messages. But your BBMD knows my BBMD because of the BACnet device table that you create. That's the only way that this works. And then on my side, when my BBMD router gets a message, it looks at it and it knows it's local or knows it's me, sends, and then it forwards that broadcast message out. And then I finally get it up here in the blue arrow, and then here's the trace going back for the IAM. So, and again, you can kind of follow along. The BACnet router will add my MAC address and my BACnet source address and my my network number, because most of the time devices do not know their own network numbers, and so the router tacks that on, so that by the time it gets to you, that information has been tacked on. So now you know my network number, which is 208, and my BACnet MAC address, and then from then on, you use that to communicate to me through your BACnet router and mine. And it's all complicated because BACnet networks can cross IP broadcast domains, and IP broadcast domains do not allow broadcast messages. So we have to sneak our way through it. Kind of. And it gets crazy. So now that you have my IAM, you know what my BACnet number, network number is, and my MAC address. So once you've done that, the BBMD's job is done, because its main purpose is to forward the broadcast messages. Now, most BBMDs are also BACnet routers. So if I live on a different BACnet network, you'll still go through the routers. But when you do that, they're behaving like routers rather than BBMDs. So, and then you have to be careful. One of the caveats is the subnets, the IP subnet addresses, the ones that are remote. If you have a local subnet address that your IP router knows about, and you're trying to send, or if your BBMD is trying to send a message to that subnet, if you have the same subnet, let's say 10.110.1.0, if that subnet lives at your building and also at my building, then the BBMDs are going to get confused. So when you set this up, you try to set up your IP subnets with different addresses to avoid that. So, okay. And then finally, some rules to live and die by. You really should only put one BBMD on an IP subnet, and really only one. Now, the standard allows you to put more than one on there, but you have to make sure that your BDT tables are correct and they don't overlap. And that gets kind of confusing. So that's why I just say, just don't do it. Just always have just one BBMD on a single IP subnet. And IP subnet is your local IP network. And then again, BBMDs do not forward the unicast messages like the read properties or whatever. But since your BBMD also is a router, then the router function in that device or in your BACnet router, then it will forward the unicast messages. Now, the number 3, that's the one that gets people, like I said, you have to create a network of BBMDs, and they have their own network. And that means you have to give them the same BACnet network number for that communication. So when you set up a BACnet router to behave as a BBMD, and all the ones that are going to talk to each other as BBMDs, that network number has to be the same on all of them, or else they'll get confused. And that, so that's just make sure you use the same one.
Okay. We had another question. At the physical layer, is there an MSTP to BACnet IP translation router that contains some kind of BBMD software layer?
Well, we have like our router, our BACnet router. It's got Ethernet or IP on one side and MSTP on the other side, so it just comes with it. I don't know of, and there might be one out there, but I don't know of somebody that you can just add a BBMD. In the old days, if I'm understanding the question right, in the old days there used to be 2 different devices. But nowadays, and it's been this way for years and years, they're the one and the same device. So you'll have a BACnet router that will have an Ethernet port and an MSTP port. And then, but it will usually have also a BBMD functionality built in. Some don't, I think, but most of them do. So if I answer the question there. Okay. Just a few more things really. And like I said, you're going to have to, I think BBMDs can get you kind of going up sideways and left and right and upside down and all that. So I would recommend going back over the slides and thinking about it. And you can always send us an email too, asking more. You can send it to tech support at kmccontrols.com as well, and they'll be happy to help you out too. So
before you move on to broadcast storms, we had one more question. So if I set up an IP network on a Jace as BBMD, that network number has to be the same as the IP network number configured in the router?
Yes, it depends. Right. If the Jace is going to act as a BBMD, yes and no. Well, what usually I recommend is you would set up two BACnet networks, one for on the Jace or whatever. You would have one network for the devices that live with you on that network. And then you set up another network just for the BBMD. And then that way it's not, you don't have to do it that way, but that makes it less confusing. So if you set up the BBMD, I would set it up as a different BACnet network, and then you would give it a different BACnet network number. And then it makes it more simple, I think. So, and I'm not sure how you do that on a Jace. And well, we won't get into Jason. Sometimes they'll route things, but then they don't always route things the way you might think. But again, I would talk to one of our tech support guys who can do it in a Jason. They'll be able to help you through that too. But again, I recommend that if you're going to set up a Jace as a BBMD, and obviously it's already a BACnet router, that you use two different BACnet network numbers or networks, one for the local devices and another one just for the BBMD communication.
Can the second network use the same port?
No, that's a good question. Whenever you set up a BACnet network, it has to use different ports if you're on the same subnet. So if your subnet's 192.168.1.0, say, I would use 47808 to talk to my local devices. And then I would use 47809, for instance, to talk to BBMDs. BACnet network numbers on the same IP subnet, I should say BACnet networks on the same IP subnet, have to use different ports. If you don't, then you're going to, do broadcast storms. And it's going to confuse everything. Okay. So broadcast storms, real quickly. If you have more than one BBMD on a single IP subnet, you're just inviting disaster. And you can try it out and you'll find out real quick. There's also, if you have, and this is in our document on how to set up BACnet networks and that, we have an application note, and I was going to put I have the IP addresses, or I'm sorry, the links later on here. So if you have more than one router on the same IP address or on same IP subnet, or even on the same MSTP trunk, you got to make sure that you're not configuring more than one network for them to be able to talk to each other. And the application note goes more into that. But we always would say, for instance, if you have two BACnet routers on the same IP as subnet, you want to have, they can both share, let's say 47808 network number one, but only one of them, if you have another network for like the BBMD, only one of them should have it. Because as soon as you put two on there, now they both are talking on the same network at the same time, and that is a no-no, and that's where you're going to get broadcast storms. And in another way that BACnet is different than IP is, in IP or IT, since it's a mesh kind of topology or a mesh kind of network, you can have all sorts of different ways of reaching and going through it, all your routers to get from one device to another. In BACnet, there can only be one way, only one path through all your routers to get from one device to another. As soon as you figure out or you set up something where you've got more than one way of getting from one device to another, that's where a broadcast storm is going to happen. Now you can see pretty quickly if you have a broadcast storm, your BACnet router by the standard should tell you that you've got a broadcast storm there. And even the standard says that when the routers detect a storm, it's supposed to disable some of the offending networks to stop the storm and that. So the storm will happen briefly and then it'll stop, but then you'll see that you cannot communicate in that. But not all BACnet routers do that well. And so you'll also notice that the traffic is very slow and it probably comes and goes. And if you look at it with a Wireshark, you'll see the broadcast whois and IAMs being sent multiple times real quickly. And that's a hint that the only reason why they're being sent multiple times is you have more than one BACnet router trying to forward those broadcast messages, and then they're pounding on each other. So they're kind of easy to do, but basically kind of easy to find. And the solution normally is you either turn off, you've got one too many networks turned on one of your routers, or you might have misconfigured the network number where they should have been the same and then they're not, or vice versa. So there's not that much that you can change in order to fix it. So it's kind of easy to fix in a way. But okay. The other topic here is making large networks. And this is, if you have a big building or whatever, this kind of in general, and we have that same application note that go through this too. I normally recommend having no more than 31 devices on an MSTP trunk. In the old days, if you wanted more than 31, you would put in a repeater. But now we have our 5051 router, and it's just as easy to put in a 5051 router in there to split up your MSTP trunk, and then it's just another network, and that makes the messaging go faster as well. If you're going from like one building to another, or where your BACnet traffic, your messages has to go through the internet, the real internet, you really ought to set up VPNs in between your BBMDs. And that's because BACnet uses UDP rather than TCP, and trying to send UDP messages through the internet becomes very unreliable. So your VPN between the two kind of makes it as one single, not one single network, but in a way one single network, and so it makes it a lot more reliable. And then you just remember you got flat devices, so just be careful sending out whois because everybody's going to see it. And you could, like in Commander, for instance, you can set up Commander to talk to more than one BACnet network, but the other BACnet networks do not know about each other. And so that really cuts down on traffic as well. But sometimes you can't do that. So this is straight from the standard. This is where they show the BBMD and the BACnet router was two different devices. And then other side there, that would be, there's an example, there's MSTP. So nowadays the red and the blue are together. So On network 1, that would be BACnet IP, and network 2 would be MSTP. And that's just without really trying to show how to talk to other BBMDs. This one here, this was a way of them, the standard saying this is how you could do it. You have one BACnet router, BACnet IP router, and then all those other segments there would have a BBMD, and then the BACnet router would be the BBMD and the single BBMD, and it would talk to them as a foreign device. The problem with that is if that one single blue BACnet router BBMD goes away, your whole thing just falls apart. So, and it puts a lot of processing requirements on that one device. So the way to do it is you have BBMDs spread throughout your different IP subnets, your BACnet subnets, and then they create their own kind of network, and I call that 999. And you can even cheat where not all your BBMDs have to know about each other. Normally only the one that is for your operator workstation needs to know about them all. So in other words, your BBMD device table does not have to be the same for all of them. You only need a BBMD only needs to know about another one if it has a device trying to talk to a device on the other BBMD. So normally you could just, in your BDT tables, you would have one entry for the BBMD where your, Chase lives or where your commander lives, and that's all you really need. Then the commander or the Chase has the table listing all the other BBMDs. And when you're going through the internet, again, you use VPNs, and this shows a VPN. And again, it's in our document, but you can, sometimes you have to use public addresses, and the document goes more into that. And it's real simple. When you use the public address on the BACnet router, you would use the address of your IP router, which is called the NAT. That's called Network Address Translator. So, but again, you can read our document for more detail on that. And then finally,
Okay.
and we're
out of time. Did you?
Okay.
I mean, I don't know how big of a deal it is to you to keep on going. I know you only have this one section left.
Yeah, this will take maybe a minute or two.
Okay.
Real simple. Okay.
All right, let's go for it.
So, okay. So efficient point passing, this only refers to MSTP because Ethernet is so fast and all that, you don't have to worry about it. So basically the concept is you have like one point, let's say the outside air temperature, one device has it and a whole bunch of other devices need to get it. And so I call that a one-to-many or a many-to-one situation. And to get that point passed quickly, what you do is you put code in the many devices and have it read the outside air rather than have the one device try to pass it to all the others. So on the left-hand side, you would have code in your one device with the outside air to pass it to all the others, but that's going to take some time because of the token cycle passing. So what you do is you put code on each of the other devices to read from it, and then it will pass faster. Even on if you're trying to write points or read points from each of the devices, kind of like the other way around, you're normally much faster to put code on each of the other devices, like to pass its occupied status. But when you do that, usually that each of those devices needs a little bit different code because you're going to use a different BV on the other device. So, but it's still a lot faster. And then finally, what I call a gatekeeper, if you have a really big network, what I tend to do is I pick one MSTP device from each of the MSTP trunks. I pass the outside air from the one device to just those gatekeepers. And then the other devices on each of those MSTP trunks, then they'll read that outside air from that one device that's dedicated on their network. Like, so again, it passes it a lot faster. So, okay. And now we're done.
Now we're done. Well, hopefully nobody's too upset that we went a little over, but I'm glad that we were able to cover all of those topics. I feel like you really had something for everybody in this today. So thank you so much for sharing your expertise with us. And I know I learned a lot, and I hope all of you did as well. As we wrap up, we want to thank you for attending KMC Controls technical webinar. This will be the final Stuck on a Bucket for the year, but we hope to see you back here after the holidays. Don't forget to follow us on social media. I did put out a poll on Facebook to see what you might be interested in as far as topics for next year. So if you haven't filled that out yet, go follow us on Facebook and fill out the poll. You can also email us at info@kmccontrols.com with any other requests or questions. And I'll be sending out a recording of today's webinar next week in case you want to review it. Dave, would you mind putting a copy of your presentation in the chat? Would they be able to get that document?
Yep,
And Dave, yeah. Thank you.
See if I can.
And again, thanks to everybody for coming. And Dave, thank you for teaching today. And everybody have a great and safe weekend.